Hello, everyone. Welcome to the Beyond Clean Expert Series. My name is Bobby Parker, and I am pleased to be hosting today for you Jeffrey Paquet, our water quality expert. Jeff, thanks for joining the show.
Thanks, Bobby. I'm really excited about being here. I want to prove that I'm more than the guy in the cartoon, that I actually exist. So I'm excited about here to be talking about water, and we got exciting things now with SD108 is out.
Oh, yes. Well, I'm looking forward to it. Jeff, this is one of my favorite conferences that we do on an annual basis because it's PowerPoint free. It's just these conversations between us and our experts, and it gives people that opportunity to see that these are real people behind these cartoons. And so I think it'll be good. As we dive into this, Jeff, why don't you do just that as we get started? Introduce to us, who is Jeffrey Paquet? Who is the guy behind the cartoon, and how did you end up being the water quality expert for Beyond Clean?
Well, it's a very interesting story. I'm actually a country boy from Vermont, and I eventually made my way to California, where I had got a degree in aerospace engineering. Worked on several programs in that space shuttle, Boeing 777, 737 next generation, the one that doesn't crash. And it just worked for Raytheon and other companies there. I found my way into healthcare in the last 7 years, where I am now the CEO of Mobile Medical mmic Medical Systems, where we have a fleet of leased medical units, primarily mobile sterile processing units. And we also have our division, VERDA Water Quality Systems, which specializes in water quality for healthcare. We came into the business because while operating our fleet of mobile sterile processing units, we encountered the same problem I think everybody encounters when they need water. We were asked to provide AMI-compliant water, and we went to the people we thought were the experts, which were basically equipment suppliers, gave them some basic information about what we needed. They gave it to us, and it failed miserably.
Okay.
Which I came to understand I think is probably fairly common.
Right.
We were an uneducated user. We weren't experts in water. We didn't understand what to ask. And you know, in deconstructing this, we went back to the equipment suppliers and say, well, we needed this. And they said, yeah, we knew you needed that. And we said, well, why didn't you give that? Well, you didn't ask us for that. So you know, we backed up. We went at it with a rigorous engineering approach, really educated ourselves about the needs, particularly in sterile processing for water. And we began to realize that it is more about an operational management problem than it is actually about an equipment issue or being an expert at water. So.
Right. And it's because water is so dynamic. It's not plug and play every situation, right? So looking forward to diving into more of that. But as we get started out the gate here, I want to tease out what you laid out for us, and that's the exciting news of ST108. And so could you introduce that for our listeners? I'm sure they're probably all aware, but you know, what is that? What's it replacing? And maybe what's the significance or categories of things we need to think about related to that?
Right. So ST108, which is the water for processing medical devices, is replacing AMI TIR34. We'll be sad to see Amy go. We love TIR34, but she was often confusing and ignored, and so her younger sister is out now, and she is a standard. So much like ST79. It's a kind of a change in authority. This is actually a standard where people will have to pay more close attention to it. A TIR is just sort of a guideline and provides you with lots of different perspectives on how to do things and recommendations, but doesn't really carry the authority that a standard does. And so SD108 is definitely a standard. It's also an ANSI standard. American National Standards Institute, which is an international recognized organization, and it defines now 3 types of water. Before, and Amy, we only had 2 types of water. Now we have 3 types of water. And the utility water, which is the water you use at sinks, and for most of the operations that you perform in sterile processing or perform with utility water. Then we have critical water, which is what you use for final rinses. And then now we have steam.
Okay. Yeah, that is new. And I guess for those who are paying careful attention to Jeff's expert series that's been released, you've talked quite a bit about those 2 types of water, of your utility water, the critical water, and then now I suppose for this interview, let's make sure that we talk about some clean steam as well, because that's an important piece of this. But let's start with that utility water piece. I think this is the one that often gets overlooked because we assume that whatever comes out of the tap is acceptable for cleaning instruments. It's going to get that final rinse later with the critical water management. But what are some of the issues that people run into with utility water that really underline the need for paying attention to your water quality in that utility water?
Right. So as you mentioned before, no 2 areas are the same. So utility water is fundamentally just the water you get from probably your municipality. Most hospitals are probably hooked to a municipal source. There may be some treatment done to it as it enters the facility. At most, it's probably softening, although sometimes there might be some pH balancing. But for the most part, it's just you get straight out of the pipe. It comes to the department. And along the way between the municipality and to your department, it's going to pick up things along the way. So what leaves the municipality isn't exactly the same water that you get in your department because it's got to go through pipes. So particularly if you have an older hospital that was built, within the last, was not built in the last 30 years, there's all sorts of plenty of stuff that it will pick up along the way. And what that stuff does is it raises the cost of maintaining your instruments because it can cause pitting, corrosion before it ever hits the washers, soaking in the sinks, going through the washers before final rinse. It is doing damage to your instruments. It will reduce the efficacy of your detergents and enzymes and all the chemicals you use because they're usually formulated for a certain specific range of water. And although they can make adjustments and do custom formulations for you, your water will change throughout the season, so you can't always count on it always being the same. So the outcome is it'll raise the cost of processing instruments. You have to maintain more inventory. It means more inspection. It means more sending instruments out to be repaired, more inspecting them when they come in and reprocessing them. So it creates more work for the SPD, and it creates the need for essentially more people in the SPD. And as we all know, it's very tough to find people. So one of the easiest ways to deal with that problem is to reduce the amount of noise. And you can reduce the amount of noise by making sure your utility water is to spec. And that would be AAMI SD 108.
Yeah, no, that makes a lot of sense. And water quality, particularly that utility water quality piece, it feels like maybe not that big of a deal and kind of an eye roller when they say that you need to have your utility water to spec. But when you think about the amount of time that instruments spend in contact with that water, it's pretty significant. And so the fact that can lead to a lot of the instrument staining and corrosion and deterioration of those instruments over time, when you really start to think about it, it does start to make a lot of sense.
Yeah, because instruments are used time and time again, and they come contact with the instruments. So maybe no one time is all that noticeable, but like the Grand Canyon, it started out with a trickle, and then holy cow! Right.
Yeah, no, that makes a lot of sense. I remember reading one of your articles about utility water, and you had one particular customer that had a utility water temperature problem at their facility, and it caused some problems with things other than just the instruments in the sink. Can you tell us a little bit about that story?
Yeah, this was kind of caught us by surprise, and maybe it's not a surprise to a lot of people, but in many parts of the United States, not in Vermont, people have problems with the water temperature coming from the municipality being warm, hot. I remember being in Arizona when I worked in the automotive industry and going to the hotel and going to drink some water and just practically spitting it out because it was so warm. It was so foreign to me. But this is a problem in many places. And what happened to us and our customer was that we were feeding utility water to the sterilizers to both cool steam jackets and to generate vacuum. Most sterilizers, steam sterilizers, have vacuum generation pumps, and they all work in the same way regardless of brand. And what happens is the water is used in the pump to actually generate the vacuum, and it is also used to cool the vacuum pump. And what happens is when water is too warm, and too warm is above 65 degrees Fahrenheit, it can potentially cause a problem with the vacuum pump. What happens is when the water in the vacuum pump gets to more than 102 degrees, so by the time warm water goes through the pump, picks up some heat, and then gets used to generate vacuum, the pump will cavitate, which means the water will actually boil in the pump because you're creating this low pressure, and at 102 degrees F, those pumps will start to boil the water inside of it, and then you will lose vacuum and you will have an aborted cycle. And that was happening continuously, and what we discovered is the water coming in was 90 degrees Fahrenheit, and it was quickly reaching 102, and we were aborting cycles. So, and interestingly enough, in section 10.3.2 in AMI SD 108, it specifically says steam sterilizers need to be fed with water that is below 60 degrees Fahrenheit.
I love that you're able to pull that off the cuff. It's like, does Jeff sleep with ST108 under his pillow at night? Is that? I believe it. No, that's really good, and a really unique story of problem solving and troubleshooting, because that's probably not the first place that you look when you're having aborted cycles in your sterilizer. And service tech is probably replacing vacuum pumps like crazy, trying to figure out what is going on with this. So
yeah, well, they found out what the problem was pretty quickly, and this isn't always a problem for people. Some people can have sterilizers that have chiller loops in them, so you can run chilled water from your hospital chillers. But you have to know to ask those questions, and you have to know to watch out for that if you have warm water.
The next practical category that you mentioned of water that our departments are going to need to be familiar with is that critical water piece of it. Can you tell me what is critical water? You identified that as kind of your final rinse water, but where is it likely to be used in the department, and what is it?
Right. So critical water is defined to a very specific spec that has a certain conductivity and pH and level of ionic contaminants and whatnot. However, what it is purified water. And the way people commonly understand it, it's RO water, it's DI water. And so it's water that has been purified. And it's usually purified by deionizing it. And you can deionize it by putting it through an RO system, or putting it through DI tanks, or both in some cases. And then what it does, so water is fascinating. It's kind of the original solvent, and that's what we use it for in sterile processing. It's a solvent. We stick our instruments in a sink, and what we expect is all the grime and dirt and blood and whatnot is going to go into solution into the water. So water that is highly purified is very unstable, and it really wants stuff to dissolve into it. And so final rinse water, or critical water, it does a really, really good job as if there's residual ionic contaminants or grime or dirt or anything that's left on there. It's a really good solution for removing all of that. It just draws everything off of things. And that's why, the instruments come out looking so nice after you've rinsed them with DI water, is because it literally takes everything, puts it in solution, washes it away.
Yeah. And Jeff, it was from you that I learned about that almost corrosive property of critical water and the specifications that are needed for the plumbing because of the deleterious effect it has on the plumbing if you don't use the right kind.
Right. Well, going back to it being a solvent, It's not just for dirt.
Right.
It will leach things out of your pipes. And so you have to be mindful of the materials you select. The OEMs and the washers and other equipment are very mindful of material selection when critical water is going to be in contact with it, because it will leach out metals and plastic organic compounds out of pipes if you're not using the right pipe.
Right. So it's typically not that copper pipe that would be delivering your utility water.
Right.
It'd be some kind of plastic looking pipe.
Right. A special type of PVC or other
Yeah.
type of plastic pipe.
So here's your technician tip for the day. If you weren't involved in the building of your department and you're just a technician working in decontam and you want to verify that there is critical water going to one of your sinks, if you look under there and you see that you've got your hot, your cold that are coming out of the wall and your typical water supply lines with, feeding up to the sinks, and then you've got a third one that's like a dark gray plastic or something going to your critical rinse water, that's not guaranteed that it's the right water, but that is a good indicator that somebody did their homework.
It is a good indicator. Yes.
Or if you've been told your whole career that, oh yeah, we've got critical rinse water at that sink, and you look and it's just teed off the cold water supply headed over there, you don't.
Not.
You probably not. So yeah, do your homework and investigate and see if you've got critical rinse water in the right places. What are some of the issues that departments run into? Because as you mentioned, water quality, it's not plug and play. Even if you have the right equipment in the facility, there's still a lot that can go wrong with critical rinse water. What are some of the issues that people run into with either setting up their system wrong or not maintaining it correctly?
Right. So the biggest problem with critical water is that it's very prone to becoming contaminated with bacteria. One of the first things you do with water when you purify it to make it critical water is you strip out all of the chlorine. So anything that's been put in the water to kill bacteria is immediately taken out. And within the matter of 4 hours, you can have water that's fine to water that's not compliant if you have some source of bacteria. And as we learned from the movie Jurassic Park, life will find a way, and there's bacteria everywhere, regardless of how well you manage stuff. So it's not simply design it right and then set and forget, because it will become contaminated with bacteria. And that's primarily the largest problem you're going to run into with your critical water, which is why you're supposed to test it monthly for bacterial components and now endotoxins every month in ST108. Because what we found is generally you, regardless of how good you are and how good your system is and how much care you take, within about a month, your critical water loop will have elevated bacteria levels in it that are beyond the specs in either TIR 34 or ST108. And when people tell us routinely, oh yeah, we disinfect that pipe once a year or quarterly, it's really scary, because I can almost guarantee we'll ask them, well, did you test your water before? Yeah. Well, it was high. It was high in bacteria. Okay. Well, did you test it 2 weeks after you disinfected it to find out when it starts to get disinfected? And the answer is no. It's just they were told that's when they got to do it, and that's when they do it. So, yeah.
Jeff, I've got flat white paint in my house on the walls, and I've got 4 kids, and so like this illustration of trying to manage
and a puppy.
You
were telling me before this.
And a puppy now, yeah. So it's like I've got so many gallons of flat white paint in my garage to try to maintain this over time, and it sounds like a similar.
It's very much like that.
Yeah, that's too funny. And you said even if you have the best water quality system set up, that maintenance and that monitoring is still important. But is there a difference between one that is well set up and a poorly set up one? You mentioned a water loop that kind of recycles through the system. What's the significance of that?
Right. So, there's definitely a difference, particularly if you had your system for, maybe 10 years or so or more. It's a good chance that you may not have a loop. And in fact, there's a lot of hospitals that don't have a loop. And what a loop is that when water leaves the equipment that's purifying it, it goes out and visits every piece of equipment, every place or point of use, as Amy calls it, where water is used. And then what isn't used is returned and is then filtered for bacteria. Because in the time that it has visited all your points of use, it has likely picked up bacteria along the way. So it goes back into a system where it goes through a UV filter, which is basically a light that destroys bacteria, and then it goes through a highly a 0.2 or sub 0.2 micron filter that helps filter out either bacteria or dead bacteria, which creates endotoxins.
Okay. So it kind of recycles the water. So it just doesn't sit swampy and dead
Right.
at
And
the
water
end of
that
the line.
sits still for more than 4 hours is almost guaranteed to become infected with bacteria. And it's important to have it move at a certain speed in the pipe continuously, or you will get what's called biofilms, which are basically colonies of bacteria. It's almost like coral reefs where some die and then they become a protective layer for others to hide. And you eventually build up this slime in your pipes, in which case you will almost always never comply with the bacterial requirements and the critical water loop, and you'll have to remove your plumbing probably.
Oh,
so
yeah. Nobody wants to go that route.
No.
Okay. Well, we are way down in the weeds here, but I do have one more question before we move on related to critical water. You mentioned that recommendation or requirement of testing at least monthly. Is there technology out there that does real-time monitoring and testing as well?
Yes. I mean, there's plenty of devices that can be inline to your water purification and your loop to do that type of thing. Of course, there's always a cost to that. Mm-hmm. There's also handheld analyzers that are relatively easy to use that you can use to test your water and get results right there. In fact, in critical water, you almost have to do that with pH, because critical water, if the sample sits for any longer than 15 minutes and it's exposed to air at all, even if you put a cap on it right after you sample it, the pH will change significantly within 15 minutes. And so you can't ship it to a lab and get an accurate result on the pH of critical water.
No, that makes a lot of sense. Well, we are quickly running out of time, Jeff. So I want to save a little bit of time here to talk about that third category in steam. Can you tell us a little bit about what those requirements look like in ST108, and specifically this idea of clean steam sterilizers? It's kind of a hot button topic for the industry right now. A lot of people are considering switching to those. Like, what's the significance of having clean steam in your department?
Right. Well, the significance of steam to the sterilization process is obviously it is the media that delivers heat to the instruments to sterilize them. And there is a direct relationship between the quality of the steam and its ability to do its job. And steam is very influenced by the water that's produced it. So if you have water that has a lot of contaminants in it, you will have steam likely that has some level of contaminants in it. And if there's enough, this is what causes wet packs and bad loads and deposits on instruments when they come out of the sterilizer that didn't seem to be there when you packed them up the first time. It's also what causes sterilizers, the inside of the chambers, to turn colors and that type of thing. So the idea is the cleaner your steam, the better the outcome all around for the department and the instruments. So the clean steam is actually a technical definition, and you'll be interested to know that Amy says that hospital and healthcare settings should never have to use clean steam. So there's a point of confusion there. Clean steam is specifically steam that is been generated from water that meets the specifications for water for injection. So this is water that you could use in dialysis or in compounding pharmacies or anything that actually goes into a patient. And the critical water that you use, say, in the department is actually magnitudes less pure than that. And what they say is that it's not necessary to generate steam from that. However, there is a big benefit to generating steam from purified water, like we use in the department, critical water. And when they say they have a clean steam sterilizer, what they're saying is that we've designed this sterilizer so that it can withstand using purified water. It doesn't have to be purified to the level of water for injection. But as we just discussed a few minutes ago, critical water is corrosive. And so clean steam sterilizers are built with materials and components that will not be dissolved by highly purified water. So that means that you can feed those sterilizers with your critical water that you use for final rinse, and it will generate steam that will be very, very pure and will provide great outcomes for you. So
that makes a lot of sense. Jeff, I worked at Circuit City in the early 2000s, and I was
I'm sure we're going somewhere with this podcast.
That's right. When I worked at Circuit City, and there was all the new flat screen HD televisions that were coming out, and there were people all the time coming in wanting to buy the new flat screen television, and they told them, like, well, you're going to need like better cable, and you have to buy these HDMI cords. So if you just take this home and plug it in, like it's not going to do anything different. So here's the tie.
A clean steam sterilizer doesn't mean you can take water from the river and it'll make clean steam. No, it has the ability to use water that's been purified, highly purified. And in fact, AMI actually doesn't have it classifies steam as a type of water, but what you're testing for is actually you're testing the steam condensate. And basically what it's saying is the steam condensate, which is what happens to the steam after you use it, it'll condense and become water again. And you measure this, and as long as it basically meets the requirements of your critical water, meaning that has low conductivity and doesn't have, the ionic contaminants, a high amount of ionic contaminants, that this meets the standard. And you can get there. You don't have to feed sterilizers with critical water to have condensate that would meet those requirements. That's why they classify the steam you use in your department as process steam, because it doesn't have to be from a clean steam sterilizer. However, if you're in those areas of the country where you have very challenging water, and places like Southern California and Texas and Florida, Illinois, places like that can have some very challenging water, and your process water may not be able to produce, in the end, steam that meets the requirements of SD-108.
Right. So that's a great tool in the toolbox then. So, Jeff, as we look to wrap this up, what advice do you have for sterile processing leaders out there who are taking all this in? They say, yeah, that's nice. There's new requirements out there. But what advice do you have for them who are looking to begin improving their water quality? What are some good first steps that they could take?
Well, first step is purchase the AMI spec.
Right.
So, and the first thing it's going to tell you in that specification is you need to form a board of people, a team of water quality that's going to be responsible for water quality in the sterile processing department. And those members are going to be somebody from executive management so that they have the authority to do what they need to do. You're going to want people that represent sterile processing, but also your downstream customers like the surgical people. You're definitely going to want facilities. And it also mentions putting someone on the team, probably from outside or maybe from inside, that is an expert in water quality. And the first thing you need to do is perform a risk assessment on what are your own risks with the type of system you have now, and then really begin to understand the spec and what the risks are, and then put together a plan with how to become compliant to that spec. It's a lot, but there are people that can help you out there. And in fact, Amy has formed several teams from the original working group that authored SD-108 that are working on some TIRs about how to implement the spec. And those will be out probably in August of next year, maybe. But Amy does recognize that it'll take a while for people to become compliant. And it's just simply looking at the spec doesn't mean you're just going to instantly be able to be compliant, that you're going to need help along the way. And that's what the TIRs are about. But I wouldn't wait, because if you're in your window for Joint Commission, they're aware of the spec, and they're going to want to know what are you doing to get there. They're probably going to recognize that you're not there, but you should be able to document that you have activity on trying to get compliant.
Yeah, that makes a lot of sense. And having that that multidisciplinary team looking at this and doing that risk assessment, that's really good advice for how to move forward, because without the data behind what your spec is, what the real risk is, you're not going to get anywhere with administration and, sinking a bunch of money into trying to fix your water quality if you don't really know what the issue is and how bad it is and what practical steps we need. And as you mentioned earlier, the big to-do in this project is not just get some new equipment installed, but it's also the upkeep, maintenance, and
it's really not about the equipment
of that system.
It's really not about the equipment. It's really about management.
Yeah, having those partners to be able to talk to about, how are we going to manage this going forward is really the key bit of it. So I appreciate that wise advice. With that, guys, we are going to go ahead and wrap this conversation. I hope you all are enjoying this expert series conference where you get to sit back and hear from some of the personal stories of our experts. I know that we just scratched the surface of a lot of these water quality conversations. And as Jeff and I alluded to throughout, water is dynamic. It's different in every situation. And what you're experiencing in your facility may be wildly different from your friend who's just one state over. And so if you've got a particular question that you have about your water quality, I'm sure that Jeff would love to speak with you about it. In fact, that's part of what the spirit of the expert series is. Each of those monthly releases have Jeff's picture on it, having a helpful article about water quality, but also includes his contact information so that you can reach out with your water quality questions. So you'll find his contact information in the session description for this session. Also, keep an eye out for those expert series releases that come out, and you can find his contact information in there. Again, Jeff, thanks so much for joining us for this criminally short conversation about water quality. I appreciate your insights today.
All right. Thanks, Bobby. We'll see you soon.
All right, sounds good. Everybody, I hope you're enjoying this conference, and until we see you next time, keep fighting dirty.